All right, let's jump right in. We're going to be talking about the essential plumbing, the critical infrastructure for the next huge wave of AI. You hear about AI agents all the time, but the big question is, how do we actually trust them? Well, the answer is in this really powerful idea, using complex semantic models for understanding, but then using simple JSON for fast, agile action. We're going to break down what that means and why it's the absolute key to building AI you can actually rely on.
And this really is the central question, isn't it? I mean, think about it. We are on the verge of letting these autonomous AI agents manage incredibly important, high-stakes parts of our lives. But that brings up a massive challenge. Before we hand over the keys to our bank accounts or our company's logistics, we have to be 100% certain that these agents will do the right thing every single time.
So here's how we're going to tackle this. First, we'll lay out the core problem with AI agents as they exist today. Then we'll build the solution, piece by piece. We're going to give them a brain so they can understand context, then hands so they can act quickly, and finally, a trust handshake to make sure everything is secure. And at the end, we'll put it all together to see what this agent-ready stack actually looks like.
You know, the fundamental issue with AI agents right now is this constant battle between their amazing power and their frustrating lack of predictability. An agent can chew through mountains of data in a second, but if that data is even a little bit ambiguous, it's prone to hallucinations, basically making stuff up or just taking a wild guess. And when there's real money on the line, well, that's a risk nobody can afford to take.
So how do we fix this? Well, the very first step is to give the agent a brain. And no, this isn't science fiction. What we're really talking about is giving the AI a rock-solid foundational understanding of your business logic. And we do that using something called a semantic model. Think of it as the AI's source of intelligence and its guardrails. So what exactly is a semantic model? The best way to think about it is as a super detailed knowledge map for your data. It doesn't just hold a number or a word, it defines what that number or word actually means in your world. It clarifies the context, the relationships, and that's what turns raw, dumb data into real, usable intelligence for a machine. And this slide just illustrates the difference perfectly. On the left, an AI sees status 1. What on earth is it supposed to do with that? Does 1 mean active, paid, shipped? Who knows? But on the right, with a semantic model in place, it sees status shipped. There's zero ambiguity. The AI knows exactly what this means and what to do next. It's a simple change that prevents a world of errors. Now, you might be wondering what kind of tech we use to build this brain. We need a language that is incredibly rich in meaning, one that can enforce super strict rules about what data is and what it isn't. And a fantastic example of this is a technology like XML. It has time-tested tools that can guarantee a piece of data means the exact same thing everywhere in the world. This provides those essential guardrails that stop the AI from just going rogue and making up its own rules. Okay, so the agent has a brain for deep understanding, but a brain needs hands to actually do things in the world, right? And that is where JSON comes in. JSON provides the quick, agile, lightweight way for our smart agent to interact with everything else.
And this comparison just says it all. Look at the left. That's the language of the brain, XML. It's descriptive, it's powerful, but it's also kind of bulky with all those tags. Now look at the right. That's JSON. It's the same information, but it's minimalist, clean, and way faster to work with. This isn't the language of rules, it's the language of action.
JSON is just perfectly suited for this role. For one, AI models are basically native speakers of JSON. It's what they're trained on. It's also super easy for developers to work with. And because it's so minimalist, it's incredibly fast to send across a network and easy for any device to process. Most importantly, it's the language that powers things like OpenAPI, which are like the instruction manuals that tell an AI how to use an API. So here's how it all works together in the real world. Step 1. The brain, that robust semantic model, holds the master data, the single source of truth. Step 2. An agent needs to do something, so it makes a request. Step 3. The system intelligently translates just the piece of data needed into lightweight JSON. And boom, step 4, the hands get that fast, easy-to-use JSON through an API. You get the best of both worlds, the strict reliability of the brain and the speed of the hands.
So we have the brain and we have the hands. But when the stakes are really high, we're talking about moving money or signing contracts, we need one last absolutely critical piece. We need what I call a trust handshake. This is the mechanism that guarantees every action is secure, verifiable, and completely unambiguous.
And at its core, this trust handshake is all about this one simple but incredibly profound idea.
It's about making sure that if two different agents in two different parts of the world are looking at the same transaction, they're seeing the exact same undeniable truth. There could be absolutely no room for interpretation.
The tool that makes this possible is called a canonical form. Canonicalization is just a fancy word for a process. It takes data that might have tiny, meaningless differences, like maybe the fields are on a different order or there's an extra zero after a decimal point, and it converts all of them into one single, standard, true format.
And this table just makes it crystal clear. Take a look at those two original JSON snippets on the left. They mean the same thing, but technically they're different strings of text. The order is swapped, and one price has an extra zero. A dumb system might get confused, but the canonicalization process is smart. It resolves them both into the exact same identical form on the right. All that ambiguity is just gone.
So why does this matter so much? Because once you have that one single, true form, you can create a digital signature for it. That makes the entire action verifiable and tamper-proof. If an AI agent is about to move $10,000 of your money, you need to be 100% sure that the request is crystal clear and completely secure. This is how you get that certainty.
All right, let's bring it all home. We've been building an agent-ready stack, a real architecture for the future of automated work. And it all stands on these three pillars: context from our semantic models, speed from our agile JSON, and trust from those verifiable canonical forms.
And this quote right here, this is the whole story in a nutshell. The semantic models are the brain. They give the AI the context it needs to understand your business. JSON gives it the hands, the speed to actually do things, and canonical forms provide that crucial handshake, the trust you need before you let it handle real-world, high-stakes transactions.
So, what we've described here isn't just a clever idea, it's the essential architecture for what's coming. As more and more companies start automating complex jobs with AI, this semantic, JSON, canonical stack becomes the non-negotiable foundation to make sure those new workflows are fast, accurate, and most importantly, trustworthy.
And that leaves us with one final, pretty important question. This future, this agentic workforce, is coming whether we're ready or not. This stack is how we prepare for it. So as you look at your own data, your own systems, the question you really need to be asking yourself is, are you ready?